Hello everyone, welcome to pipebench.com. Um, Today I would like to introduce a major update on one of our HDD calculation tools. The previous one we had was online for a long time, multiple years now, and the previous version was mainly focused on the traditional HDD design, assuming only we have a vertical drill path. Over the years, we have received many questions on whether we have ability to design for compound bands, which means we will have both horizontal band and a vertical band scenarios, which is getting fairly common in the industry. And that's why we have spent some time on working on these major updates, and I'm very happy to announce that we finally have that feature on our tools now. So I want to make this video to introduce this new feature and to show you how to use it. So when you log in our website, either you can use the 7-day tryout or you subscribe to this tool. You will see the default geometry design at the very beginning is the same as before. We only have a section view, pretty much just a traditional HDD design, and we keep the pretty much the old features of keeping the unit options for imperial or metric. It's pretty easy to just click and you can convert. We also keep the ground service data, so you could copy paste on from Excel sheet directly, or you can manually put in the ground profile to load it there. For example, I can show you how to do it. For example, we just put in the middle point and say 4. So you just need the first number is gonna be your stationing, and the second is gonna be your elevation, and then you could just press load calculation and see the data points now become 3, and then you just close it. You can see your ground profiles has been entered. Of course, for the real project, probably get some survey data that you could come here and copy paste the survey based on the stationing and elevation. You could generate the ground profile pretty easily. And scroll down here, you can see on the left side is the typical HDD path geometry. This is the same as before. You have the basic parameter you have to put it in, the entry, elevation, stationing, could be 0, could be whatever the stationing you have for the real section of your design, entry angle, radius. This is the vertical radius from the entry side. And then there's a depth of pipe at a horizontal section. So just want to clarify, this is the depth compared to the entry point. This is not elevation. If you can tell that for this default value is 64 foot. It means it's going to be 64 foot from the entry point all the way down. It is not elevation per se, which the real elevation should be around 930. And then you put the exit angle and exit side radius curvature and elevation and stationing of your end point. So this this part is pretty much the same as before, but what is new is on this side is the new feature for users to enter horizontal band. We know sometimes when we design HDD geometry, there's scenarios we have to use horizontal band to change the course of the drill based on the geo conditions, based on the obstacles we will see or surveyed for the project. This is pretty common, especially for the urban HDD design. And so we have these features for users to very conveniently put a horizontal band. So I'm going to show you a few scenarios. So first scenario is very common, that we only want to enter a horizontal band for the straight section. So that eliminated compound band, which is greatly increased the complexity of the drill. So in this case, for example, we're gonna just enter a horizontal band per se between station 600 and 800. So in this case, we click here, add a horizontal band. We put in the start stationing of the horizontal band we want to put it in, like I said, 600 to 800. And the bending radius, this is the horizontal bending radius. So in this case, let's say we keep it a little bit larger than the vertical, which is 1200 feet. Let's say we keep 1400 feet. And then for direction, this is really just for horizontal direction, you could either go on one side or another side. So this is just about directions. And we can, for now, for this one, we can put it left or right, but for now, let's leave it at the left for now. So then we click Add Band. As you can tell, the geometry graph has changed to add this plan view. This plan view is also include the points we default have with the vertical, but we added a section of horizontal band from HB1S and HB1E, which means horizontal band 1 start and horizontal band 1 end. So as you can tell, this will show the plan view of your HDD drill. So no longer just a vertical view. It's pretty easy for you to see the plan and section detail. So I know during the design, a lot of times we have to rely on the CAD team to generate the plan section for us to review. I think this is a great tool for engineers to do everything by yourself without involving the CAD capacity. You could just check the geometry by yourself and to see if everything works. So again, this is generated a horizontal band. It tells you one of the band is already going to be shown here for 600 to 800 feet stationing with a radius of 1400 foot left. And then once you put that in, the HDD profile is going to be updated by itself to include this horizontal band section to calculate the length of different segments. Of course, you can get a total kind of updated here. And also everything below of the pullback load will automatically generate a section of this pipe for the tool itself to calculate all the key parameters such as different force and eventually get the pulling load and to combine with the total pulling load. So another thing is that this, again, for installation load and stress, will be uploaded to and compare with the allowable. Make sure at any point of the drill is still within the allowable. And also for the analyze of the operational stress, and then you will calculate the minimal radius curvature too. In this case, is still at 1200 because the input of a horizontal band is 1400, is larger. So for this complete drill, the minimal radius of curvature is still 1200 foot. And then also this operational stresses, it's going to calculate by itself based on the inputs. The only thing related to the geometry is the minimal radius curvature. So it's still remaining unchanged. Now let's go back to the horizontal band. Let's say this is, I know it's very unusual, but let's say this is not the only horizontal band you want to put it in. Let's say you want to put another horizontal band at the entry side curvature to create a compound band, for example, right? So let's say you want to have between 200 and 300, you add another horizontal band. You can just put it here, go to 200 to 300 stationing, and then this is gonna be compound band, so we need to make sure we consider that the compound band radius is within allowable. It doesn't be too small. So we already have a vertical band of 1200 feet. In this case, we have to go a little bit larger horizontal band to make sure the stress is okay. Again, you can go do the iteration using this tool to figure out the bending radius gonna work geometry wise and also stress. But here, let's say we put a 2000, right? And then this time we're gonna try put a right basically on the other direction of the horizontal, and then we just click add. Now you can see we have two horizontal band inputs. If you're going back to the plan view, you can tell now it's generate a compound band section at the between PC1 and PT1. This is the vertical curvature, and then it's just generate this horizontal band, and also your previous horizontal band input between now it becomes number to HB2 and HB2 start and end. So you can tell based on your horizontal band, not only you're gonna have a compound band highlight, also this plan view geometry can be updated by itself. Same thing, you're gonna see all these key points on the vertical section view too. As you can tell, there's a compound band section highlighted. There is gonna be another horizontal band on the straight sections. And then you come here, since we have a compound band now, it's gonna generate a compound band details, tell you where to start and finish, what's the vertical radius in that section, and what's the horizontal radius, which is 2000, we just put it in, and it will calculate the compound band radius, which is the and this number here. Also, because of this horizontal band, the total drill length will be changed slightly. And if you're going down here, everything is generated by itself. The different horizontal band, different station elevation, and section length you could use to compare to your CAD files, and also the underground conditions to double check the check the elevation, make sure everything has acceptable clearance. This is all the same, still the design parameter as the typical HDD. And then to the pull back loads, same thing. You have a both section. All this little section will break it out by itself. Now you have pretty much a lot of more column than used to be. Pretty much different column considers only vertical band, is a compound band, is a horizontal band, or is a straight. Everything has different inputs, different length, different angle, so you will calculate the different radius and also different force, different effective pipe. We're gonna affect it, total pulling load. You will see different frictions, and then so you will obtain all this total pulling load cumulative ones, and until you get to the maximum pulling load, you will see the pipe's gonna see. Similar things for the installation loads and stress check. You will have all these breakdown sections based on your inputs. They will check everything and make sure that every scenario will be checked and compared to the allowable limits. Same thing here. Now you can tell for the operational stress section, the minimum radius of curvature now reduced to 1029. And this is because the tool itself calculate compared to the vertical band along, the horizontal band along, and compound band to figure out the minimal radius of the design curvature. And then that will calculate your operational stress, especially the bending stress. And it's going to impact the total stress check. So I know in the real construction design effort, the minimal radius of curvature is actually going to be could be even lower than the design curvature, because what the pipe's capacity could even take an even smaller radius. So if you calculate the radius of curvature of a true minimal you want to use, you could just tick here, and then you can manually change this number. For example, if you calculate and decide the minimal radius of curvature for the driller is going to be 900 feet, you just put in 900 feet, it's going to calculate the bending stress accordingly. And of course, it's going to change the limits. And of course, you get too small, let's say go to 400, you start see everything failing. So in this way, you could tell whether your minimal radius is acceptable or not. So you could do a little bit iteration here. In this case, we're gonna just keep it to the default as calculated by itself. Now I circle back. You can have kind of feeling of how we're gonna do the horizontal band. Again, it's highly unusual, but you could even have scenarios. For example, you can put even more horizontal band if you want to, even though that's almost never seen. Having too many bands is generally not a good practice for the drill. So if you want to delete any bands or revise it, you could just click it to change this parameter, and it's gonna update it by itself. For example, if you go to like 350, you change the radius to 1800%, and it's gonna just update it by itself, and everything is gonna be updated accordingly, right? In this case, if you want to delete anything, you see the little cross here, and just so you can remove it. I say you want to remove this horizontal band, and give you a window and then you say click, and then that band is gonna be gone. The compound band is gonna be gone, so it's gonna remain your section here. Let's say if we want to have a horizontal band starting midway of this vertical band, and now also graduate to the straight section. That we have considered that too. Sometimes it happens. For example, I'm gonna just add this to start like 300, right? So let's say we change this horizontal band to start at 300 foot, and then let's change the radius to let's say 1900 and update. As you can tell, it's gonna update the band by itself. That also you have a longer horizontal band, but your compound you will have a shorter section of a compound band. This compound band will be, because we started here, basically this section from 300 to the end of this vertical curvature, you will have a compound band, and then they will show you, even calculate where the compound band is going to be. It's going to be starting at 300, which is our starting point, and then the end point of compound band is going to be actually PT1 is at a station near 427.9, and also it calculate the result compound band radius. It changes the length, and also everything below geometry wise, calculation, load calculation, breakdown is going to be updated by itself. So pretty convenient in our opinion. I think this is really the first one, and that in the industry that anyone has this kind of features, and easy for to put the horizontal band. Again, you could do the same thing for, you could add another one for this side. Let's say to go to 900, and let's say 1200, radius 2100, for example. Go to another direction per se, and then yes, so you will have a second horizontal band, a compound section here, and your plan view will be updated accordingly. So again, this is the new feature we introduced in. All the others remain the same. How you put a ground profile, how you put in the pipes basic parameters and change the size. There's a drop down. You can use the custom too, and schedule wall thickness. Let's say if you have a special wall thickness, you could just manually put that too. Easy selection for the grade, and then all the other parameters pretty much the same as before. So I want to just quickly put this video together to show you the new features. Again, at the end, we provide a cloud save and open features. For example, for this one, if you want to save this to the cloud, you could just say HDD design 1, like I say, just click save. It's actually automatically save it to the cloud of this file, and then next time if you want to retrieve it, or you, let's say you want to change anything, let's say you want to remove one of the compound band, and then you want to update it, you can just going down, let's say you can just say update it, right? and then the file is going to update it by itself. It's gonna in a database. So as you can tell, this band is gone. Now, how do you get the files you have saved? So once you logged in, you could go to the files and receipt. So this is where all the saved files is. So for example, you just save this file. You can delete this file. You can open it from here. Then you can retrieve your old files, or there will be subscription, order history, where you find the receipt. So it's very convenient for you to get the files you have. And another options is to save it to your local drive. This means download. This is gonna create a JSON file of a local drive you could send to your coworker or some multiple people working on it. Once you have all your subscriptions, you could just send them to download and open the files. And also the same thing for all our tools. You can generate a report, PDF report about it. In this case, I would just show you that you can put the project info. It's going to show you all your inputs, all the graphs you put it in. So it's pretty nice. So yeah, that's pretty much the things I want to present. It's mainly about awareness of a new feature. We think this is really cool. I think it's going to help you a lot for your project. But if you have any questions or feedback, please reach out to us through PipeEng, the help at pipeeng.com. Anyway, thank you so much. Wish you have a great day.